The dyslexic brain processes information differently than most minds. While traditional approaches focus on sequential, step-by-step analysis, dyslexic thinking often involves recognizing patterns, relationships, and structures in ways that research suggests may lead to unique insights. This appears to be more than simply compensation for reading difficulties. Emerging evidence points toward a fundamentally different cognitive approach that may offer distinct advantages in certain domains. Hey there, neurospicy folks! I'm Dr. Monty, and I'm an ADHD psychologist with a special interest in all things neurodivergent neuroscience. If you enjoy my videos, please consider subscribing to my channel to help me grow and bring more scientific understanding and awareness to a larger audience. Thanks so much! For decades, we've understood dyslexia backwards. The standard narrative frames it as a reading disorder, a broken phonological system that struggles to connect letters to sounds. Schools focus on remediation. Parents worry about falling behind. The entire conversation centers on what dyslexic brains can't do well. This deficit model feels intuitive because it matches what we observe in classrooms. Dyslexic children do struggle with reading fluency, spelling, and sequential processing. They often appear slower in traditional academic tasks. The phonological theory, developed in the 1970s and 1980s, provided a clear mechanism. If you can't efficiently map written symbols to sounds, reading becomes laborious. But this explanation, while partially correct, misses something that researchers are beginning to document. It's like describing a Formula One race car as defective because it performs poorly as a family sedan. The deficit model struggles to account for observational reports that dyslexic individuals sometimes gravitate toward careers in entrepreneurship, architecture, engineering, and creative fields. Though we should note that systematic data on career patterns remains limited, and these observations may reflect selection bias rather than inherent advantages. The emerging hypothesis suggests that dyslexic brains aren't just struggling with reading. They may be optimized for something entirely different, something our text-heavy educational system rarely measures or values: pattern-based thinking. To understand how pattern-based thinking works, imagine two different approaches to assembling a 1,000-piece jigsaw puzzle. Most people start with the edges, then work systematically through sections: sky pieces here, building pieces there. They follow a sequential, step-by-step process. Now imagine someone who dumps all the pieces out and immediately starts seeing relationships. They notice that this curved blue piece shares a shadow pattern with that angular brown piece 20 pieces away. They spot recurring textures and color gradients that reveal the puzzle's underlying structure before they've placed a single piece. This is closer to how some dyslexic minds may process information. In 2011, Matthew Schneps and his colleagues at the Harvard-Smithsonian Center for Astrophysics published findings that individuals with dyslexia showed advantages at detecting patterns in complex visual datasets, specifically the kind of analysis crucial for spotting distant galaxies or unusual stellar formations. In their study of 17 dyslexic and 35 non-dyslexic astrophysicists, the dyslexic researchers demonstrated superior performance at identifying meaningful patterns in simulated astronomical data that appeared as visual noise to others. However, this was a relatively small sample, and we should emphasize that these are preliminary findings that need replication with much larger groups before we can draw firm conclusions. The advantage appeared primarily in tasks involving global pattern detection, rather than local feature analysis. This advantage may stem from fundamental differences in neural architecture. In 2012, MIT neuroscientist John Gabrieli and his team published research showing that dyslexic brains exhibit different patterns of neural adaptation, the process by which neurons become less responsive to repeated stimuli. In their study using functional MRI, they found that while this creates challenges in reading, where rapid recognition of familiar letter patterns is crucial, It appeared to provide advantages in certain types of pattern detection tasks. Again, we're looking at preliminary evidence. The effect sizes were moderate, and not all dyslexic participants showed identical patterns. Think of neural adaptation like habituation. When you first enter a room with a ticking clock, you notice the sound. Within minutes, your brain filters it out. This is adaptive for most situations. It prevents sensory overload and lets you focus on new, potentially important information. But some dyslexic brains may maintain heightened sensitivity to repeated patterns. They continue noticing variations and relationships that adapted brains would ignore. Gabrieli's team found that when they showed participants series of faces, words, and objects, some dyslexic brains maintained stronger activation in relevant processing regions. They kept seeing the stimuli with fresh eyes, detecting subtle variations and connections that neurotypical brains had already dismissed as irrelevant. However, this pattern wasn't universal. Individual differences were substantial, and we're still working to understand when and why these differences emerge. The visual spatial processing advantages show up in multiple studies, though with varying effect sizes and significant limitations. In 2003, Catya von Károlyi and her colleagues at the University of Wisconsin published research demonstrating that dyslexic college students outperformed controls on certain spatial tasks involving three-dimensional visualization and mental rotation. In their study of 16 dyslexic and 16 non-dyslexic students, the dyslexic group showed advantages in tasks requiring them to identify impossible three-dimensional figures. The effect was significant, but appeared most strongly in participants with the most severe reading difficulties. These are intriguing results, but with only 32 total participants, they represent early-stage evidence that requires substantial replication. This connects to what researchers call global processing versus local processing. Most people analyze scenes by focusing on details first, then build up to the big picture. Some dyslexic minds may work in reverse. They grasp overall patterns and structures immediately, then fill in specifics. It's why some dyslexic architects report being able to envision how a building will feel to walk through before they've drawn a single floor plan, though we lack systematic research documenting this phenomenon. The pattern recognition may extend to abstract domains, though the evidence here is even more preliminary. A 2017 study by Logan and Pentamonti found that some dyslexic entrepreneurs showed enhanced ability to detect patterns in business scenarios and market data compared to matched controls. However, this research involved only 24 participants, and the findings represent very early-stage evidence that needs extensive replication with larger, more diverse samples before we can draw any firm conclusions about strategic thinking advantages. But here's where the science gets complicated. Not all dyslexic individuals show identical cognitive profiles. The research I've described captures trends that appear in some studies with some participants, but dyslexia exists on a spectrum with significant individual variation. Some dyslexic people may be primarily visual spatial thinkers who struggle with phonological processing. Others might show strong pattern recognition but have additional challenges with working memory or processing speed. Still others could demonstrate creative advantages while experiencing significant difficulties with executive function. The dyslexic superpower narrative, while containing potentially important insights, can inadvertently minimize very real struggles or create pressure to excel in compensatory areas. There's also the replication challenge that pervades this field. Many of the most exciting findings about dyslexic advantages come from relatively small studies that represent preliminary evidence rather than established science. Schneps' astronomy research involved dozens, not hundreds, of participants. Von Károlyi's spatial advantage study included 32 total participants. The field desperately needs larger, more diverse samples to understand how consistently these advantages appear across different populations and contexts, if they appear consistently at all. The effect sizes matter too. When studies do find advantages, they're often moderate rather than dramatic. A dyslexic advantage in pattern detection might translate to performing 15 to 20% better on specific tasks, not the revolutionary cognitive differences that popular accounts sometimes suggest. These are potentially meaningful differences, but they exist alongside very real challenges in other domains. Cultural factors complicate the picture further. The potential advantages of pattern-based thinking become most apparent in environments that value spatial reasoning, creative problem-solving, and innovative thinking. In educational systems that prioritize standardized testing and sequential skill building, these strengths may never emerge or be recognized. A dyslexic child in rural Bangladesh faces different challenges and opportunities than one in Silicon Valley. We also don't fully understand the developmental trajectory. Some dyslexic advantages seem to emerge later, the late bloomer phenomenon, where individuals who struggled in elementary school excel in college or careers. But we lack longitudinal studies tracking how pattern-based thinking develops across lifespans, or what environmental factors nurture versus suppress these abilities. The relationship between dyslexic thinking and modern technology raises additional questions. Does our increasingly visual, multimedia world play to dyslexic strengths? Or do new forms of information processing create different challenges? The research simply hasn't caught up to our rapidly changing cognitive environment. Understanding dyslexia as potentially involving pattern-based thinking, rather than simply representing a reading disorder, could change how we approach education, career development, and human potential, though we must emphasize that this remains an emerging hypothesis rather than established fact. If you're dyslexic yourself, this research suggests considering a different relationship with your own mind. Those moments when you immediately grasp complex relationships that others need explained step by step, when you can envision solutions to problems that haven't been fully articulated yet, when you detect patterns in data, behavior, or systems that seem obvious to you but invisible to colleagues. These might be expressions of a different kind of cognitive processing, though it's important to remember that individual experiences vary enormously. This doesn't mean reading difficulties aren't real or don't need support. The challenges are genuine and often significant. But it suggests approaching remediation differently. Instead of viewing pattern-based thinking as a distraction from real learning, educational approaches might leverage these potential strengths. Teaching reading through pattern recognition, using visual spatial methods to reinforce phonological skills, or allowing alternative ways to demonstrate knowledge. For parents and educators, these findings deserve consideration while maintaining realistic expectations. That child who seems slow at worksheets but builds incredibly complex structures with blocks? Who struggles with spelling but creates elaborate, coherent fantasy worlds? Who can't remember math facts but immediately grasps geometric relationships? They may be demonstrating a different form of cognitive processing that our current assessment methods fail to capture. Or they may simply be developing at their own pace in different domains. In professional contexts, this research suggests the potential value of cognitive diversity for complex problem solving. The entrepreneur who sees market opportunities others miss. The engineer who intuitively grasps how systems will interact. The designer who creates solutions that feel inevitable once implemented. They may be leveraging pattern-based thinking in ways that complement more linear analytical approaches, though we lack systematic evidence for these professional advantages. The broader implication involves recognizing cognitive diversity as a potential resource rather than simply a problem to be fixed. In a world that may increasingly reward the ability to detect patterns and see relationships, different approaches to processing information could prove valuable, though this remains speculative rather than demonstrated. The dyslexic brain reveals something important about human cognitive diversity. What looks like disability in one context might represent advantage in another. Pattern-based thinking, the tendency to see relationships, detect structures, and grasp wholes before parts, may not be simply compensation for poor reading skills. Emerging research suggests it could represent a fundamentally different way of processing information, though we must emphasize that this evidence remains preliminary and requires substantial replication. The challenges dyslexic individuals face with reading and sequential processing are genuine and often significant. But the question isn't only whether dyslexic minds can learn to read better. It's also whether we can create environments that recognize and nurture different forms of intelligence while providing appropriate support for real difficulties. In a world that potentially rewards the ability to find meaning in complexity, understanding how different minds work may prove increasingly valuable. The dyslexic brain, with its possible optimization for pattern-based thinking, represents not simply a disorder, but potentially a different approach to understanding reality, one that comes with both genuine challenges and possible advantages that we're only beginning to understand.